Okay.
Okay, so today we're going to look at the statistics chapter. We finished it in the 2:30 class, so we should finish it in here as well, which will give us a little breathing room for the other chapters before our first exam. So as with anything, we start a new topic. We're going to learn some definitions. You will not be asked to recite definitions on an exam, but you will need to know what these things mean to a degree. So we start out with the first one, population. Population of a study group or of a study is the group of that the collected data is intended to describe. That's who we're hoping to get data about. As an example, we have a newspaper website contains a poll asking people their opinion on a recent news article. What's the population of this poll? All right, so newspaper readers. The next term we have is called a parameter. This is a value, such as an average or a percentage, that can be calculated using all the data from the population. And of course, we have the census. The survey of the entire population is called a census. Then we have what's called a sample. A sample is a smaller subset of the entire population, ideally one that is fairly representative of the whole population. So if you go on into statistics a little further than we do, you'll be looking at samples. You won't be doing entire populations. Which brings us to statistic. A statistic is a value, such as an average or percentage, calculated using the data from a sample. So statistics come from samples, parameters come from population. Easy to remember, P for parameter, P for population, S for statistic, S for sample. So you have a researcher wants to know how citizens of Pensacola felt about a voter initiative. To study this, she goes to the Cordova Mall and randomly selects 500 shoppers and asks them their opinion. 60% indicate they are supportive of the initiative. So what is the sample in this example? $500 shoppers. Very good. What is the population? What do we want to know? I'm sorry, I'm going to... Actually, we're going to go beyond that. What does the researcher want to know? We're using the sample from the mall in order to determine what the population or citizens of Pensacola. So with that, 60%, is it a sample or a parameter, or is it a statistic or a parameter? Well, 60% of what?
Of the population.
So that's 500 shoppers. 60% indicates 60% of who? The people she asked. And she don't know what the people she didn't ask believe. So in this case, the 60% is relation to the sample. And therefore, it is a statistic. That makes sense? It's 60% of the people that were asked, 60% of the 500 shoppers. We don't know for sure. We can use this as a sample of the entire population, but we don't know for sure. Who has time to ask everybody? Okay, next thing we look at is called quantitative and qualitative data. Qualitative data are pieces of information that allow us to classify the objects under investigation in various categories. Could be something as simple as the color of cars in a parking lot. That would be quantitative or qualitative. It's the quality of the cars, the color. Quantitative data are responses that are numerical in nature and with which we can perform meaningful arithmetic calculations. So it's not just numbers. We have to be able to do things like calculate an average. So, qualitative or quantitative? Conduct a survey to determine the name of the favorite movie that each person in math class saw in a movie theater. Is it qualitative or quantitative? Qualitative. I don't think I can find an average movie title. I guess we could take the most common words and throw that together and come up with a title. Survey asks the number of movies you have seen in the theater in the past 12 months. Quantitative or qualitative? Quantitative, I can figure out. Which class are you in? In person? Is the name you're showing the name you have registered under? Because I don't have you listed on that. Are you sure you're not just in the completely online? Yeah, your attendance is not taken through the meetings. The meetings are optional for your class. I think there's several more of you that are coming, which I don't have a problem with. You too. But if you're in a strictly online class, you don't have to be here for these. Yes, I got you, Ash.
Jesus Christ.
Well, you're not in the person class. Now, it does get confusing. And is the name you're using the name you registered under? If so, you're not in the synchronous class. You would be in the asynchronous class, which is strictly online. You're welcome to join these meetings, but you don't have to. Okay? So that, I don't have you listed on that class, so you are strictly online. Okay, so we finished that one. Okay, now we're gonna get to the tricky ones. Remember what we said now. Suppose we gather respondents' zip codes in a survey to track their geographical location. Is this information qualitative or quantitative? How many qualitatives with an L? How many quantitatives with an N? How many I have no flipping idea? This week?
Qualitative.
Remember now, I know you think numbers, so it's quantity numbers. But can we add up everybody's zip code and then divide by the number of zip codes and come up with an average zip code? No. So while it's a number, it's not quantitative. It is qualitative. Easy mistake to make. Next one's even worse. So we take a survey about a restaurant you most recently ate at. It includes a question. How would you rate your experience with these possible answers? 1, it was awful. 2, it was just okay. 3, I liked it. 4, it was great. 5, it was best meal ever. Is it qualitative or quantitative?
Go and add, like, see how many people did what, and chose what.
So if you use the number ratings, it's quantitative because you can add them up and average, find an average rating. However, if you use this part, it's qualitative. Because of course we can't find an average between the word descriptions. So it's a little tricky. Any questions on that?
So what would be the correct answer if this was a test, like on the test?
It wouldn't be on a test
Yeah.
because both answers are correct depending on how you look at it. I'll be honest with you. Actually, yeah, qualitative and quantitative are on the exam. Essentially, what's on the homework will be what's on the exam. And it's very obvious. At least I think it is. Although I have my doubts sometimes. Now we come to the reading portion of the program. Okay, and again, I'm not going to ask definitions. This is not English. This is math. We need to know a general idea of what these terms mean. So if I ask you a question about it, you'll know. So we start with sampling bias, which occurs when every member of the population doesn't have equal likelihood of being in a sample, because that's our goal. A random sample is one in which each member of the population has an equal probability of being chosen. That's what we're trying for. A simple random sample is one in which every member of the population and any group of members has an equal probability of being chosen. Again, I really don't see where we're going to need to differentiate between the two in this class. So, if we could somehow identify all likely voters in the country, put each of their names on a piece of paper, toss the slips into a very large hat, and draw 10,000 slips out of the hat, we would have a simple random sample. Everybody has the same chance of being picked. Of course, I'd hate to be the one shaking that hat up or pulling out 10,000 names. And as I said, the reading portion. Okay, some more information about different types of sampling. One of the things we run into is called sampling variability. The natural variation of samples is called sampling variability. Variability. It's unavoidable and expected in random sampling, and in most cases is not an issue. Typically, if you really try hard enough to get a random sample, there's gonna be some variability, but it's not gonna be enough to be a problem. The next sampling method we talk about is stratified sampling, and stratified sampling of population is divided into a number of subgroups or strata. And random samples are taken from each subgroup with sample sizes proportional to the size of the subgroup in the population. So I could divide everybody up into subgroups. Subgroup would be one of my 3 classes. Now, since my 230 class is about twice as big as this one, if I randomly picked 4 people from this classroom, I would randomly pick 8 people from that classroom. Because the number of people you pick is proportional to the size of the strata. Or, suppose in a particular state that previous data indicated that the electorate was comprised of 39% Democrats, 37% Republicans, and 24% independents. In a sample of 100 people, or 1,000 people. So first, our strata are Democrats, Republicans, Independents. We would expect to get about 390 Democrats, 39% of 1,000, 370 Republicans, and 240 Independents. To accomplish this, they could randomly select 390 people from among those voters known to be Democrat, 370 from those known to be Republicans, and 240 from those with no party affiliation. This is stratified sampling, the strata being the political party. Similar, quota sampling is a variation on stratified sampling, wherein samples are collected in each subgroup until the desired quota is met. So suppose the pollsters call people at random, but once they have met their quota of 390 Democrats, they're only going to gather people who do not identify themselves as Democrat. This is called quota. Once I reach my quota of 390 Democrats, I don't want to talk to any more Democrats. I met my quota. The next sampling method we learn is called cluster sampling. The population is divided into subgroups or clusters, and a set of subgroups are selected to be in the sample. So this is similar to stratified sampling. We divide everybody up into groups, but in stratified, we sample a certain number of people from each group based on its size. In cluster sampling, we randomly pick the clusters instead of the people in it. So if the college wanted to survey students, and students are already divided into classes, they could randomly select 10 classes and give the survey to all the students in those classes. This would be called cluster sampling. Now, a lot depends on how they do that too. Because I'm sure most of you are taking more than 1 classes. So there's a chance you could be in 2 of those or 3. So they'd have to be careful of that using this method. That's one of the issues with it. I know this is a lot, but I'll be perfectly honest with you. Anything beyond quantitative and qualitative will not be on the test. We're just exposing you to this so you have a well-rounded mathematical education. At least that's what they tell me to say. Well, how many of you are planning on taking statistics? This chapter and the next 2 will help you. Oh. Well, we may get ahead of them, and I don't know how they do that course right now. So, but we'll look into data collection and probability. Might help, might not. Next up is a systematic sampling, in which every nth member of the population is selected to be in the sample. So to select the sample using the systematic sampling, Maybe a pollster calls every 100th name in the phone book. Now, systematic sample, does everybody know what a phone book is? They don't make them anymore, do they? Systematic sample is not as random as simple random sample. For example, if your name is Albert Aardvark and your sister Alexis Aardvark is right after you in the phone book, there's no way you both could be in the sample. But we can still get acceptable samples from this method. It does end, I promise. Next, we have what's called convenient sampling and voluntary sampling. Convenient sampling is samples chosen by selecting whoever is convenient. So maybe I want to take a sample from this class. Instead of randomly picking you, I'm lazy. I'm just going to see the front row and that's it. That way I don't have to walk any further. Voluntary response sampling is allowing the sample to volunteer. So we ask you to complete a survey, but you don't have to if you don't want to. So we have a pollster who stands on a street corner and interviews the first 100 people who agree to speak to him. Is this a convenient sample? Yes, we wait for people to walk up to him. A website has a survey asking readers to give their opinion on a tax proposal. This is a self-selected sample or voluntary response sample, which respondents volunteer. So if you don't want to, you don't have to, your choice. You see those a lot. Online retailers where they ask you, will you fill out this survey, that type of thing. Now we're looking at bias. We have different sources of bias. First one being sampling bias. This happens when a sample is not representative of the population. Can have voluntary response bias. This tends to occur with we have a sample of volunteers because well, who responds to those online surveys? First of all, it has to be people that go online. And you know, some of us old folks don't go online, so we wouldn't be sampled, so it wouldn't be random. There's a self-interest study bias that occurs when the researchers have an interest in the outcome. There's response bias when the responder gives inaccurate responses for any reason. There's a perceived lack of anonymity when the responder fears giving an honest answer might negatively affect them. And there's my personal favorite, the loaded question. When the question wording influences the responses. And then there's non-response bias. When people refuse to participate in the study, they can influence the validity of the outcome. So I come up with this perfect sample. It represents the country perfectly. But then half the people don't respond. Well, don't represent the country perfectly anymore. So let's look at some examples of this and see what we have here. So consider a recent study which found that chewing gum may raise math grades in teenagers. Sounds great, doesn't it? Just to know that all through high school, all you had to do was chew gum. However, the study was conducted by the Wrigley Science Institute, a branch of the Wrigley Chewing Gum Company. Now, this is a self-interest study, one in which the researchers have a vested interest in the outcome of the study. Now, this doesn't necessarily ensure that the study was biased, but it definitely doesn't pass the sniff test or the chew test, I guess. Think about it. If you have math anxiety, which several people do, and you start chewing gum, the gum might take your mind off the anxiety. You might do better. Could be true. Really could. Good. You have an issue like that? So I don't have a problem with you chewing gum. As long as you don't put it under the desk. I think that's fair. Now, if you're online, you're welcome to put it under the desk at home. I don't know. Okay, we have a survey that asks people, when was the last time you visited your doctor? This might suffer from response bias since many people might not remember exactly when the last time they saw a doctor. Or they may not want you to know when the last time they saw a doctor was. But it doesn't mention that one. Same principle though. They don't want to know or they don't remember. The survey asked participants a question about their reactions with members of other races. Here, a perceived lack of anonymity could influence the outcome. The respondent might not want to be perceived as a racist, even if they are, and give an untruthful answer. So, I don't think I'm going any deeper into that one. Math, not politics. We'll stay safe with the chewing gum company. An employer puts out a survey asking their employees if they have a drug abuse problem and need treatment help. Now here, answering truthfully might have consequences. Responses might not be accurate if the employees do not feel their responses are anonymous or fear retribution from the employer. I'm not going to tell you I'm addicted to drugs because you'll probably fire me. May not say that's why, but most likely it would be. A survey asked, do you support funding research of alternative energy sources to reduce our reliance on high polluting fossil fuels? Of course, this is an example of a loaded or leading question whose wording leads the respondent towards an answer. Here's the big words here. High polluting. We're telling you this is bad stuff. It pollutes. Not just a little bit, a lot. So you should hate it and want us to research. Telephone poll asked a question. Do you often have time to relax and read a book? And 50% of the people called refused to answer the survey. It is unlikely that the result will be representative of the entire population. And this is an example of non-response bias introduced by people refusing to participate in a study or dropping out of an experiment. When people refuse to participate, we can no longer be certain that our sample is representative of the population. Personally, I think there's a problem with this from the beginning, the telephone poll. I'm not talking about the thing out by the highway. There are people that don't have phones. Is it a cell phone telephone poll or a landline? Because if it's cell phone, there's people that don't have cell phone. If it's landline, most people don't have landlines. So there's other issues with this poll as well, but the main one is the non-response. Now we talk about observational studies and experiments. It's easy to get these two things confused. An observational study is a study based on observations or measurements. An experiment is a study in which the effects of a treatment are measured. So yes, an experiment we're going to watch, but we're going to do something first. An observational study, we're just going to watch. So some examples of experiments. Pharmaceutical company tests a new medicine for treating Alzheimer's by administering the drug to 50 elderly patients with recent diagnosis. In this case, the treatment is a new drug. It's what they did. They gave them a drug. A gym tests out a new weight loss program by enlisting 30 volunteers to try out the program. The treatment here is the new program. You test a new kitchen cleaner by buying a bottle and cleaning your kitchen. The new cleaner is the treatment in this case. And a psychology researcher explores the effect of music on temperament by measuring people's temperament. So they do something. Okay, so suppose a middle school finds that their students are not scoring well on a state standardized math test. They decide to run an experiment to see if an alternate curriculum would improve scores. To run the test, they hire a math specialist to come in and teach a class using the new curriculum. To their delight, they see an improvement in test scores. Now, does anybody see a problem with this particular example? What's the treatment? Is that it? Is that the only thing they did? A math specialist, not just a math teacher. So which one caused the improvement? Or could it just be that they're retaking the test? And maybe that's what caused the improvement. Or could it be they see that the school's looking at this, so maybe they better do better? So this brings to mind what we call confounding, which occurs when there are two potential variables or more that could have caused the outcome, and it's not possible to determine which actually caused the result. So it could have been one, could have been other, could have been both of them, could be something completely different. We can't tell. I have a drug company study about weight loss pill might report that people lost an average of 8 pounds while using their drug. However, in the fine print, you find a statement saying that participants were encouraged to also diet and exercise. It's not clear in this case whether the weight loss is due to the pill, to the diet and exercise, or a combination of both. Confounding has occurred. Researchers conduct an experiment to determine whether students will perform better on an arithmetic test if they listen to music during the test. They first give the student a test without music, then give a similar test while the student listens to music. In this case, student might perform better on the second test regardless of the music, simply because it was the second test and they're warmed up or they know in advance what's on it. Kind of like your test, you'll know in advance what's on it. But I'm only giving it to you once. Now we talk about control groups and treatment groups. When using a control group, the participants are divided into 2 or more groups, typically a control group and a treatment group. The treatment group receives the treatment being tested. The control group does not receive the treatment. So again, an example. To determine if a 2-day prep course would help high school students improve their scores on the SAT test, a group of students was randomly divided into 2 subgroups. The first group, the treatment group, was given a 2-day prep course. The second group, the control group, was not given a prep course. Afterwards, both groups were given the SAT. So we have a control group without it, test treatment group with it. A company testing a new plant food grows 2 crops of plants in adjacent fields. The treatment group receiving the new plant food, the control group not. The crop yield would then be compared. By growing them at the same time in adjacent fields, They are controlling for weather and other confounding factors. However, if it's done in Florida, not necessarily. And as I'm sure you know, it can rain on one side of the street and not the other. You may have heard of this. The placebo effect is when the effectiveness of a treatment is influenced by a patient's perception of how effective they think the treatment will be. So a result might be seen even if the treatment is ineffectual. Now, this next example, I've actually researched this. It's true. They actually did this. They didn't just make this up. A study found that when doing painful dental tooth extractions, patients told they were receiving a strong painkiller while actually receiving a saltwater injection found as much pain relief as patients receiving a dose of morphine. It's amazing what the human mind can do. What gets me though is these people did this to these people, not realizing that it would work. So here, I'm going to give you some salt water and I'm going to yank your teeth out and we'll see if it hurts. Okay. Placebo effect is a dummy treatment given actually a placebo is a dummy treatment given to control the placebo effect. An experiment that gives the control group a placebo is called a placebo-controlled experiment. So, in a study for a new medicine that is dispensed in pill form, a sugar pill could be used as a placebo. That's typical, that's standard. Although I think most pills are bitter, so when they're tasting this pill that tastes like sugar, they're probably going to realize it. So I don't know. But that's here nor there as far as what we're doing. In a study of the effect of alcohol on memory, a non-alcoholic beer might be given to the control group as a placebo. In a study of a frozen meal diet plan, the treatment group could receive the diet food and the control group could be given a standard frozen meal stripped of their original packaging. So they don't know what they're getting. So a blind study is one in which the participant does not know whether or not they are receiving the treatment or the placebo. A double-blind study is one in which those interacting with the participants don't know who is in the treatment group and who is in the control group. In a study about antidepressant medicine, you would not want the psychological evaluator to know whether the patient is in a treatment or a control group either, as it might influence their evaluation. So the experiment should be conducted as double-blind. However, if a researcher is testing whether a new fabric can withstand fire, she simply needs to torch multiple samples of the factor. No need for a control group. Did you enjoy me reading to you? So that finishes this up. I know I scheduled us to have a week for it, but we'll probably need that extra time for the next two chapters. So to reiterate, in-class test is the Thursday before the homework is due, which is sometime in the end of September. The homework is due October 1st. Those of you online, the homework is due October 1st for the first 4 chapters, as is exam 1. Does anybody have any questions on anything that we covered today? So next time we'll start learning about describing data. And I'm not talking about the character in Star Trek Next Generation. Did everybody sign the roll sheet? Let's do this.